Hello people of the internet. On Sunday we had unexpected outage of the copper service and we are not yet 100% sure what happened there, but I think I know. When debugging the problem, why we are not building, I discovered this traceback and I actually just restarted, unfortunately, the service basically, so it continues working and there is no outage anymore. And then went debugging afterward, and then I found out, hey, maybe I know what the problem was, but I could not confirm anymore. Stupid, silly me, right? So yeah, whatever. I think it was caused by this. So basically, what was happening? Why there was an outage? Like Copper Frontend, the website, it worked fine. It normally showed you could submit builds, you could do everything here. There wasn't any problem. However, we had a large queue of builds that wasn't being processed. And so basically we had like here maybe 1,000 or 2,000 waiting builds, pending builds. However, running was only, I don't know, 10 or something like that. So yeah, we weren't doing anything basically. And I have seen that before, and I have found in the logs this traceback, which could be a good indicator basically. So you can see that in background worker build, this is the task that processes builds. Basically, somewhere deep in that is this XML-RPC error. And if we scroll somewhere, here, close ticket. So the resalloc client is trying to close ticket basically, and that's a problem I have seen before. If we go to GitHub resalloc, this one, and we find maybe this one. So yeah, this is what I've reported on January, and basically here I wasn't like here in this we can see this was called by by the copper code, right? Copper backend package. So this was called by the copper code, but here I had a similar issue where the copper wasn't involved at all. I was just running on the command line this resalloc client tool, and I was trying to ticket close a ticket, and basically I don't know if the error is the same here, but I don't really know. But you can see it was caused by close ticket, and here is the close ticket, right? So I think this is the same issue, and the last time this happened, yeah, it was basically the same. So what happened? The copper backend gave some builder machine to some build to process it, to build it, to build that package. And once the build finished, it wanted to basically call the resalloc close ticket to close that ticket and return the machine back to the pool. But since the close ticket was timeouting, the builder machine could never be returned to the pool, and therefore like all of them were taken even though they were doing nothing, right? it kind of makes sense what happened there. So yeah, and basically the fix is very easy. Like, we restart the resalloc and everything starts working again. And since this kicked us in the face on January, then on the weekend, this weekend on Sunday, 2 days ago, and definitely January wasn't the first time. I have seen this bug maybe 4 times before that. So this is really annoying, and we have no idea when this happens. It can happen on a weekend, it can happen during the night, and there is nobody to fix that promptly, so we have outages. And it sucks, and yeah. The problem is, I have tried to debug that issue before. My coworker tried to debug that issue before. My other coworker tried to debug that issue before. Much smarter engineers than me. Nobody could figure out what's wrong and how to reproduce this with 100% 100% reproducer, like that happens every time. So we didn't know how to fix that, how to reproduce that, right? The thing is, we see a traceback here. Sure, we could catch that traceback, right? In client, no, this is not our code. Somewhere is our code. This is our code. Resalloc client. So wherever we do this call, we could catch this, so this traceback doesn't happen, right? We could print a pretty user message, couldn't connect to the server. Yeah, that's nice, whatever, but that doesn't actually solve the problem for us, because it will only print a pretty user error, but the server is still down, we still cannot close the tickets, and we still have an outage. So the problem is, or how I imagine to fix the problem is, on the server side, we somehow need to handle if the socket or whatever crashes, or whatever is the right word, and make sure to recover from that, right? So what I imagine in my head, which will not work, is something like okay, we figure out the server crashed, the socket crashed somehow. I don't know the words for that. Doesn't really matter. It crashed. So we will recreate the Python object or whatever that maintains the connection. I don't really know. So something like that. Or maybe we could somehow figure out it is not alive, and we could crash the whole resalloc server, maybe, because then we could handle that by systemd, and it could be, hey, resalloc crashed, I'm restarting resalloc. That could work as well. But this half-ass crash that it crashes the connection, we cannot connect using the XML-RPC, but the resalloc server is still running, is the worst case scenario for us, basically. So as I said, this will be complicated, and I doubt we will fix it. I doubt we will figure that out. But let's give it an hour, and we will see if we can at least understand what is happening and understand how to work with it. So I would maybe say let's ignore the one that we have seen from the copper code, because the reproducer here would be from the copper code, which is, we don't need to necessarily involve that part there. We could do it more simply and assume it's the same problem and use just the resalloc client and resalloc server to work with this. So let's try to find code for resalloc ticket close, right? So let's go to resalloc. I should probably rebase, but the problem is happening for a very long time. Yeah, it doesn't really matter what version we have, but we have the latest one. Now, in this, in Emacs, we will find resalloc and we'll find client. So it's ticket close. Let's search for close here. Yeah, and that seems to be the one called from the copper code, because I remember there was something like call close ticket. We can show that close ticket, right? Client 92. Yeah, that's the one. So we are probably reproducing both of those issues at the same time. Good. Now, I don't really know much about XML-RPC. This code wasn't, like, majority of the code wasn't done by me here, but from watching YouTube and watching stuff about front-end development in JavaScript, I know there is something like tRPC, which allows to call TypeScript functions on the server, calling TypeScript functions. I mean, on the client, calling TypeScript functions that are on the server, and I think RPC should be a generalization of that. So I suppose you should be able, from the client, basically call a function that is defined on the server, right? And the XML part, I suppose, is just the format that the server and client exchange between themselves. So I suppose if this was a modern library, it would be something like JSON RPC. I don't know. So whatever. I think basically the only important part for us is, like, this is a client code and it has some connection to the server, I presume, and it can call, I think, an actual function on server that is, I suppose, a normal Python function, and this is the argument for that. So let's confirm my thinking. Let's go to resalloc. Now, I have no idea where that function would be. So you know what? We are going to see git grep this. So we have some API and it has close ticket. So seems like I was right, maybe, at least partially. API close ticket, right? So this is a normal function and it does this. And it is defined where? In some server API. In some server API, which you know is an old code since it extends object. Now the server API, like, I suppose the problem isn't in this code. because like we are seeing like connection problems, right? So I think the problem is actually, see, it's create connection here. So we actually don't get into this code. So more likely the problem is like what? Self-create connection. Oh, this is not our code. This is HTTP. Okay. So where is our code? Our code is here. Resalloc client, I've called this. Yeah, I don't know about this fcall, really. But it is supposed to be resalloc client line 35. 35. Yeah, here, okay. Oh, so there is some nice wrapper. Where is this? Okay, oh, so this wraps the connection. Okay. So, and where is the connection used? Not here. Nice. So somebody uses this ticket, right? Connection self. Oh, okay, so this was the client code as well, only a bit lower. Connection self. But who creates the object of the, yeah, here, okay. No, this is a test. Resalloc agent spawner. What the hell is this? Is this a server code or client code? Agents part agent spawner daemon. I suppose this is, I suppose that was a server code, right? So either way, this takes a connection string from the outside. That is understandable. This is the test, right? But yeah, basically, so it's an host name and port where the resalloc server is supposed to be running. A request survives server restart. True. Okay. I don't know if we do that or not. By the way, let me grab the connection. This is test CLI, this is the dispatcher client. Here in resalloc binary, this is the one I was interested in. So resalloc binary is like means executable here, not actually binary. So this is the resalloc client connection. Yeah, so right, so this is the command line resalloc client. It creates the connection, and then it only handles the commands. So ticket close should be there. So it just calls the get ticket and close. Interesting. Why get ticket and then ticket? Oh, so ticket close is the that's the one we are actually calling, right? So makes sense. So we create like whatever we pass to this connection object when creating it makes sense. It's just the connection string, which is the host name and the port. That's reasonable. And then we create this connection, which is, and here the nonsense start. The mess, I would rather say. Wrapped XML-RPC client. What is this? So this takes connection string and survive server restart. Those are the same parameters. And it creates this. So it creates self-connection from C XML-RPC. So why do we have this try except? I suppose one of those is the modern way of doing this, and if it fails, then we are not in modern Python, which basically means we are on, I don't know, rel 8 or something like that, and therefore we use the client from this older implementation. We can make sure blame. See, it's some compat between Python 2 and Python 3, right? So we should be able to, like, I suppose this is a new Python, say this is standard Python library. So it is in standard Python library now. It didn't used to be, seems like. Or maybe it was just a different name. Anyway, so we have this this server proxy. Maybe let's take a look at it. Server proxy here. So we have this. And when we call, so here is where our here is where it goes from an error in our code to like the errors in somewhere else. So this is the last place in our code where we actually see that we can actually see the traceback. So yeah, okay, so we on the connection, we try to call, or not maybe call, just get a name. What is name? I suppose this is client. I want this one. And I want to go to, yeah, this is the close, and you cannot see because we are scrolled badly, but you can see now. So self connection call, and we are putting a name is the close ticket, and then we are putting the args. So here we are basically trying to get the function so that we can call it. The fcall is, it's a bad name, I would say. It should be basically f, like the function, not the call itself, but whatever. So we get that, and then in a loop, for some reason, just to handle errors probably, we try to call that function with the arguments we have. So we are finally trying to call close ticket with the ID. Now if socket error, then we print. And if not, self-survive server restart, then we are raising an exception. That is what happens because see, when we created the connection in the binary previously, we didn't specify the survive. So whatever is the default, that happens, and default is false. So yeah, this is the exception we are throwing probably. And now we also handle RP exception, which is, I guess, a generic error from the XML-RPC. But this probably never happens because we get to here. Not sure. So let me take a look into the Copper backend. I'm doing some stuff here on the Copper frontend, don't mind that. This is backend, I'm doing some stuff here, don't mind that. But in a new tab, let's take a look at the vim var log resalloc main log, right? Whatever we raised, there should at least be print before that. Some socket error. Sock error. What is sock error? Oh, the exception, right? So we should at least print the exception here, or print the exception here. I don't know what happened, but yeah, right? Unless this was completely unhandled. So XML, nothing. XML, yeah, we don't see anything. Is that weird or what? How old is the log file? If we scroll to the very top, this is... Oh, it was maybe rotated already. Shoot, because I can see 22nd, and the error we had in production was 22nd. All right, 10 in the morning. Now this is 2 in the morning, so actually it should be here. But it wasn't. So I'm not really sure. Wait, this is still client. Stupid me. This is still client, so this wouldn't be in the log. No. This no. So wait, this could be the problem actually. We did no. this is from the copper code. So maybe this exception that we see here could come from that. I don't know. I'm not sure, but it's definitely client-side handling. So that's not helpful for us, right? The last time we did that on the client. Oh yeah, yeah. So see this, I think, or I don't know which one of those is that. Either way, there is a line which is like a string representation of some exception, I think, and then there is a traceback. So when we did resalloc close something, it did this error handling, right? We caught the error. I think it was this one, because then we raised an exception, and here we wouldn't, and we would try again. So it was definitely this one. So the error handling here on the client side is there. But okay, so basically socket error. Socket error. Does our server documentation say anything about socket error? Socket error. No. So like, now we are getting to the Linux stuff that I'm really supposed to know, but what exactly is a socket and can it be destroyed? And I don't have like good answers for that. So let me use Claude, let me ask stuff. So we'll create a Claude session for this project, and we will ask. And I will tell you what I think before we ask the question. So can I somehow break a socket so that this one cannot properly connect to it and fail with the socket error exception? So what I think is the sockets are somehow, I don't know if represented or available or whatever is the right word, but they are somehow tied to a file on disk, right? Am I completely wrong? So if we, for example, break the permissions for that file, or if we somehow remove that file, it will stop working, right? And it is possible the server will not notice. Some of the breakages maybe, some of the breakages maybe not. I'm not sure. So that's where I want to start, and we will see, right? So maybe we will discover that I'm completely stupid and doesn't have to do anything with files, but let's try. it takes a little before this, before the agent shell properly starts a new session for a project. In the new versions, they improved it, and it starts the connection immediately when running the agent shell. So it would be creating the connection while I was blabbering about what I think. But this is slower than expected. Let's, in the meantime, maybe ask the same question to ChatGPT. Here is a practical way to trigger that. Why? Because the port is wrong, or what is the, probably, I suppose. What do we have in our, we have connection timed out. We have connection timed out. Force a timeout. But this is, yeah, this is useful when we would want to like handle the client error handling, right? We could fake a timeout and something like that, but that's not a way to reproduce our server failure. Now, kill the server mid request. That's basically what I want to do, but I don't know how to kill it. I don't want to stop the whole server. By the way, this still okay. I don't want to stop the whole server. I want to break the socket. Break the socket. So socket is represented by some file on disk, right? Sometimes. Yeah, sure. So yeah, this is basically what I meant. Okay, so we have socket, so no file contents, just a name. If you delete, new connection fail. See, and this is exactly what I was thinking, right? So let's go to resalloc. No, let's go to, by the way, what is wrong here? Let's go to my containers that are running locally. Here I have resalloc container. Yeah, so this is for the like local Copper development, right? I have the Copper front-end container, I have the Copper back-end container and stuff. Let me run the front-end server. So let's take a look if it is running before we try to do stuff. Right. So this is running. One of the containers is a container for resalloc. In the production, we have the resalloc service on the Copper backend because we are running like an actual VMs, like actual machines. But for development we use containers, and this is a separate container. We should be yeah, so we should make sure the server is running, right? We could check the logs. I wanted to check running processes, but clearly the package for psutil or whatever is that is not installed in the container, so we can do that. We could check the logs. We could also do resalloc client and then whatever call to the server. So ticket list. No, and yeah, there is resalloc client, and there is also resalloc main, which has the ticket list. There are no tickets. We can do resource list. And you would think, hey, this server is running, but actually, but actually the resalloc main, I think, doesn't call the server actually. It just connects to the database on its own. So this is not a client-server thing. I think this is a standalone tool that works with the database directly. I'm not sure, I don't really care. Let's see if we can, I don't know, create a ticket using the resalloc tool. So this definitely is the one that uses the XML-RPC to communicate with the server. So we can do ticket, I suppose. And we need to do some tag, and the tag I think doesn't have any validation. I think it can be just foo. Yeah, and we have a ticket, so we were able to communicate with the server. We can do resalloc ticket check, stupid me, to yeah, so we have information about the ticket. It is not processed. Okay, cool. Sorry about that. So our server is definitely running. Now, can we find this, but for the resalloc server? Let's ask, so that we don't have to peruse the documentation. Where does the Python this create the file? It doesn't. It creates TCP socket. Okay. Okay, then we are screwed. I wanted to remove that file and see if new connections fail the way we thought. When it would be created? Only if explicitly. Okay, so let's take a look how we create, how we use it on the server. Maybe we are actually binding it to a socket file. So server, I don't know. So in the API, it wasn't that, right? Let's do it differently. Let's go to main. This is the resalloc code base. And let's do git grep XML-RPC in resalloc server. Resalloc server here. So we have main. We have main, okay. I could have known that. Main.py. Main.py. And we will search for XML-RPC. So we have this weird thing, I suppose, yeah, that's equals a wrap. Wow. Socket server, that comes from where exactly? Socket server, okay. Okay. Poof. Okay. So we have this thing. And we create that instance. Serve forever. Yeah. There is no bind to a local file. Quick way to verify. I suppose lsof will not be in the container as well. Great. Let's do exec user root and dnf install lsof. Okay. While we are at it, let's install htop. We may need it. Okay. And if we do if we take a look at the vim, it is vim etc resalloc server YAML. So this is localhost. Whatever secrets are here can be leaked. They are none. Okay. So this is the domain, and we are using default port. So I guess this one. If not, we will have to look into the code, whatever is there, how hard coded. So I think we do something like this. It doesn't print anything. It doesn't print anything. So lsof, this is, I suppose, everything. I don't know why we are getting permission denied here. We are root, aren't we? Oh, so I don't know. I don't know how to read this actually. I don't think we see ports here, do we? What is E? Let's take a look into the config of the server port. So this is the default port. Yeah, that's the one. Okay, so how can I see what is listening on this port? The thing is, we did that and we didn't get any results, which is weird. We don't have netstat, of course. DNF install netstat. Okay, so something is listening. If we do, yeah, okay, so it found stuff. I don't know what port, what process it is, but does it really matter? I don't think it really matters. Okay, let's try this one. I suppose this is, yeah, did it help us? It didn't. This is the bit, or not really? I don't know. Do we care is the question. I don't think we really care. This is obviously open and we are connecting to it. Okay. Let's try this. I have this in my code. It sucks we cannot use Claude here. Let me try once again. Yo! So I have this. And then this, right? And then this. Does this create a socket file on my disk or not? No. Okay. Okay. Now, there is a question, which is very straightforward. Like, can I close a TCP socket? So no, I want to close it from the outside. So can I close it from the outside, from the Linux command line? What you can do is kill the process. Okay, we can kill it. Okay, so this is threaded, right? So what if we kill the process or the thread that is handling this? Maybe the resalloc server, the parent process, will still work, only the thread will die, and then that closes the socket. Could that be? So I want my PS. DNF install PS won't work. Yeah, it works nice. Somebody did that alias. I'm thankful for that. I never remember this proc whatever proc ng. whatever, I cannot even read it. PS AUX. So this is a resalloc server. Okay, that's AUXF. I expected this to have some children, but it clearly doesn't. Let's would, you know what, let's at least do ChatGPT in command line in Emacs, so that we don't have to switch to the browser and flashbang everybody and so on. So here is some debugging from that I did before, doesn't really matter. You know what, we'll kill it so that there is not the kill it, no, and we'll start a new one. So there is no context pollution by previous questions about Emacs and stuff. What was the question? Yeah, would PS AUXF print me threads? No. To see threads. Okay. Okay. So if we do this. Okay, cool. Cool. And if we do this, we can, like, there are so many options. Let's see, why not? We know the bit is 1, right? So yeah, okay. Okay, so we know we have a manager, thread 1, whatever that is, and the watcher. And they have same bit because those are threads, but I suppose this is thread ID and this is 1, 13, 14. So can I kill a process? Can I kill a thread using its date? Sometimes, but it is not a clean kill. Just okay. So each thread is a kernel task with its own ID that exists under. You can signal a specific thread if you target its state. Why killing only a thread usually doesn't work how you expect. So, okay, most terminating signals, even if the signal is delivered on one thread, kills the process, are special and effectively act on the whole thread group in practice. Okay. Will likely. Now we will try that. So we will try that. I don't know what sick user 1 is. We will try that. We will try that first. Whatever happens, happens. Then we will try probably without any signal, so the default one, and then we will try the -9 to like force it. Do we like, okay, which of those? What is thread 1 and what is watcher? Git grep thread 1. Okay, thread 1 isn't here. So it's, do we have thread? Since we have threading thread, I would say it's the thread 1. But maybe let's take a look at watcher. Watcher is in manager. Manager. Watcher. Okay, so see, this is something completely different. I know what watcher watches, but I think that's something else. I think the thread 1 is actually this. So let's experiment. Oops, I didn't. What is here? Yeah, you could see that, no problem. I wanted to go here actually. So if we kill s, we will copy it, and we will put the sig user 1 here. Okay, fine. We will use the thread 1 ID. So let's try that. Now pass AOIC, no, we need to do this. So thread 1 still lives. We didn't kill anything, it seems. We can do, we can jump to sudo resalloc. Resalloc. Or we can do sudo u resalloc, and we can do resalloc ticket check, right? So that we don't have to switch manually the user every time. And there is somewhere the ticket ID that we resource list tag check, this one. Right, so as a resalloc user, we are going to run the resalloc command with this like arguments, and it still works. We didn't kill anything. Now, what if we get rid of this sig user 1? ChatGPT warns us this will probably kill the whole process, so this will probably kill the whole container. We will see. We are still in the container. What about this? So this still runs, and therefore I suppose this still runs. Okay. What if we do this? We are still in the container. This still runs and this still works. Okay, so we did absolutely nothing. So let's do, I did this and this when 13 is the tit and it didn't kill anything. So we are right about an hour of the episode. I want to continue for a little bit because this is interesting. So let's try to continue a little until we face the wall. So would almost certainly, it did fuck all. So nothing happened. Usually it didn't signal the thread, you think. On most systems are typically in thousands, so we could of course check out the exit code. Why not? It's 0. Very common. Belongs to another. You can't kill it without the root. We don't see this. You are in a container. If you got the tit from inside container, this is only meaningful inside the PID namespace. On the host, it will be, of course, it is a kernel thread, it is not. Can we see what is here? Okay, thread 1. And we have some stuff. Okay, I think everything is exactly as we wanted, right? I am inside a container and running and not working from my host system at all. I am root inside the container and printing proc 13 whatever confirms it is the correct ID. Do you also find ChatGPT is really annoying? Like, I use Claude for this exact thing. Like, I ask it questions, and the output is usually very short, and the output usually doesn't presume I'm doing like stuff that I don't want to do. Like, usually it's concise and kind of precise. This is just a lot of possible steps and nothing actually useful. Where is the... See, it's so long I don't even know where my question was here. If you are killing a thread, but the process immediately responds, that I think of, but it would had a different ID then, no? If I killed it and it respond, it would have a different did, no? Often yes, but not guaranteed. Well, okay. So yeah, yeah, exactly. So if we take a look at this, This is where it started. Check the task start time. Okay. If we compare it with 1, it's okay. No, let's do it differently. We have this one. Now we will run the kill command. So this one is the most. This one has the biggest chance to kill it actually, and it doesn't change, right? So step D is uninterruptible. Okay, we can check that. Whatever. So we can even like put it, put it here so it is happy. Getting messages. Okay. Can you answer me, please? Can please something work today? Oh, finally. See, it spawns a kilometer-long stuff, but you are not actually signaling the task you think you are. Okay, let's play along for a little longer. I'm a bit annoyed and... Okay, so, okay. Are you happy now? What could we... Let me do a quick Google search. Can I kill Linux thread by its state? You cannot kill kernel threads. Sure. No. I meant, can I kill thread by the... Let's do it this way then. Yeah, this one. Threads are integral part of the process, cannot be killed outside of it. Sends a signal to the thread. Okay. Okay. Sends a signal to a thread. Cool. So do we have to kill? Didn't install the kill? No. Or this. Okay, so this is a C function, right? Right. This is a C documentation for a C function, tkill and tgkill. There are no glibc wrappers for the system calls. Can I call these? Let's ask very stupidly from the command line, which I know is not the correct answer, a correct question. These are C functions. We would have to write a C program to call these, but maybe it will fill in some blanks here. Yeah, I really didn't want that. Can you write a Python program instead, so that I don't have to compile it and so on? What the hell? What is this brutality? What is this monstrosity? Simplest as possible, only for x86 64. Yeah, well, that's better. Okay. Okay, that looks better. We will try that. Vim, let's do tkill.py. Let's put it here. And if we call it, it will be missing some parameters. So tgid, tid, and sig. We know our TID, which is 13, and our sig will be 9, but what's the TGID? Can we... There was the command somewhere here. Can we do TGID? Oh, we can. TGID is 1. Cool. Okay, let's do this. What happened? Something didn't happen. Still 13. And we still can sudo. Yeah, we can still do that. Fuck. Okay. So I think this is maybe end of this route. Let's take So doesn't work. Anyway, I have this, and where is this used? gr server. So we have, what is synchronizer. There is so much weird stuff. Sync. And then I somehow need to crash the server, the thread, the server from the outside world. Separate. Stop event. Crash the whole process on demand. If your goal is to make the program die, you can trigger deliberate hard exit. Crash now. OS kill. Oh, that's on the pit. That's useless. That's useless. I want to make the program crash, but I need only the thread crash, not the whole process. And I need to pee while this computes. By the way, I had some ideas, so we will see what was the answer here, and then we will try them out. So tell me, I don't want to chat, man. If outside world, another machine, no. Another process, yes. Expose without corporation. The heck? Okay, different idea completely. We are not getting an like refuse to connect or what, I don't know, like the random connection error. We are specifically getting the connection timeout, right? So what would, do we have Claude or not? No. What would cause maybe let's put the whole the part of the exception here, right? So we know the problem is timeout error. When none of the attempted addresses could complete a TCP within the timeout. In practice, it means the SYN handshake never completed. Firewall. Yeah, that was one of the things I was thinking before the recording. Actually, we could temporarily put there a firewall to reject everything, even though it is localhost. I don't know if it will work or not. IPv6 server-side issues. Yeah. And also, yeah, could it be that basically there is so much shit going on the server that the resalloc simply cannot connect, cannot process in time, basically. So what I was thinking, like, what happens if, for example, there is a problem with a database, like resalloc uses database, right? So what if there is a problem in the connection to the database and the resalloc client asks resalloc server to give it some data, resalloc server asks database, that part takes too long, and therefore it times out on the client. Like, I'm not sure if that's the exact problem we have in production, but maybe it's at least a reproducer. I'm not sure. What database do we use here? That's the question. Do we use Postgres? Do we use like local? Yeah, we use SQLite. We use SQLite, but in production, what do we use in production? SSH. We are in production. Are there any secrets in this file? Just to be sure, let me go on the backend dev in case I need to rotate them. Server. Yeah, we use Postgres actually in production. So imagine a scenario where we cannot connect to this database, and therefore it causes problems. That could be interesting. By the way, I was doing some stuff somewhere. Where was it? It was front end. Okay, it was front end, so that's fine. I don't want to crash a process that is running from yesterday in my... Oh, it finished. Cool. It finished. So good. We can try this experiment. So let's go on a front-end dev. It should normally work. Like, it should normally work in the... it is slow. That's the thing I was doing yesterday, by the way. It loads now. So it works. If we go to a root user and we system-still stop not resalloc but Postgres, we stop it, right? Come on. Yeah, the reason why it is slow is all of its memory is gone and almost all of its swap is gone, and it is because of Redis, and I was trying to fix that yesterday, but I was waiting for this to finish. So yeah, don't mind that, it will be fixed soon. However, we stopped the service. This doesn't work now. So what if we go to backend dev, right? This one server that tries to connect here. What if we try? Are we resalloc? Who am I? Yeah, we are resalloc. So if we do resalloc, I don't know, ticket check, we can do one. How is it possible? It can actually connect to the database. It uses this database. Wait. This means localhost probably, right? System-still status Postgres. Yeah. Okay. So it's a different database. That's fine. Let's start this one then, because it doesn't really matter. I was automatically jumping to conclusions because I thought we have the shared Postgres server for both of those, but okay, it seems they are different ones, no problem. So we will work only on backend dev. And what if we stop the service? Now I'm getting a phone call which I don't want to take. So Postgres is stopped. I wanted to go to resalloc user and check the ticket now. And this will time out. Please time out. Please time out. Of course, it needs to take at least 30 seconds, maybe 60 seconds, maybe even longer, whatever the timeout is. I remember when I reproduced this in the January or whatever month that it was, it took a while before the XML-RPC traceback actually appeared. So don't get our hopes too much up, but I think it will happen. I think it will happen. Come on, come on, come on, come on. We want to see the traceback. And by the way, while waiting, we can check how long is running the Postgres on production, right? So system still status this. We are not a root user here, so I don't know if it will work, hopefully. If it is running 2 days, then it was started automatically by me restarting the resalloc server. No, it is running for 3 months. Okay, so it definitely did not happen that the database was down on the weekend. So like crash of the database wasn't the root cause of the issue. But it still could be a reproducer. I'm quite surprised that this didn't time out yet, but I still think it will. Like the other option is it will take forever and we will sit here for many hours. But I think it needs to crash in minutes, right? And even though if the crash of the database wasn't actually the problem, it would be a nice reproducer. Potentially. Maybe. I'm not sure. What will it help us if this is the kind of reproducer? Because we could same as well just put time.sleep in our code somewhere and make sure and make it time out that way. Will it help us to recover from the problems on on the server. I don't think it will actually, so maybe this is completely useless as well. Right, because I don't know, if we go to the API, for example, close ticket, or I don't know, check get ticket, wait ticket, I don't know, whatever. I don't know. Let's do close ticket. If we do this and like put time sleep here, I don't know, 999, it will of course probably timeout as well, but that doesn't really help us, does it? Because we still need to figure out how to recover from node watcher main. So let's take a look at the documentation about serve forever. Where is the documentation for that? Okay. Daemon threads and allow none. Daemon. Okay, so the thing is, we have this monstrosity of a wrap. So this could be from this or from threading mixin. Threading mixin. Let's search here. That would be daemon threads, which indicates whether or not the server should wait for thread termination. You should set the flag explicitly if you would like threads to behave autonomously. The default is false. What do? We do true. Use demonic threads by setting do not wait until threads complete. Change the version. Server close and server close now waits until all child processes threads complete. Add a new block on close for the pre-37 behavior. I don't know what that means. Now waits until all child processes complete. We are running a server, nothing ever completes here. No? Serve forever. Handle requests until an explicit shutdown. Ignores the timeout attribute. Also calls which may be used. Okay. Okay, that's not useful as well, probably. Socket object. So maybe we will get into, okay, this doesn't seem to be timeouting, so okay, it doesn't seem to be even a valid reproducer. Default actions to print the trace back and continue. Okay, I don't really know what we are going to do next. What is the synchronizer? Let's take a look at the synchronizer as well. So, threading condition. Does this do anything? Server sync. Maybe in this server sync, nothing. Like. Okay. Okay. I said we are not going to finish this problem. We will not. As I said, it's not easy, and I don't know yet. So I need a pause. I need to think about it more, and then try a different approach. So maybe after lunch we will continue working on this, or maybe I will continue working on this alone. We will see. So what I'm thinking is I probably will have to run the resalloc server on the front end, so I can put a debugger there and I can change the code and play with it. That shouldn't be hard. I will then try to probably experiment with these booleans that we had, the daemon threads. There was some changes in Python 3.7, so I will probably play with those options, and I can see there are some handle timeout function, handle request, and I don't know what. We also have server close, so I will, yeah, we can access the socket. So I will try to see what's available there, and I will also try to just call the server shutdown, right? What happens if we do that? So maybe somehow we leak the maybe somehow from somewhere in the code we actually call the server shutdown. I don't know. If we quickly git grep shutdown, server shutdown, tests. So in the main we have shutdown on 3 places. Shutdown. Finally. Okay. So that's not, yeah, that's not it probably. But yeah, we will try stuff. Yeah, we try to debug that in the, like, from outside of the process. In this session it didn't work, so the next session we will try to debug that from within the process itself. Yeah, another thing that we could try later after this playing with stuff would be like writing a client that tries to overload the server. So I will create basically a script that spawns, I don't know, 10 threads, and in all of them it will just send requests to the client. Maybe that somehow gets it stuck somehow. It's possible because on Copper backend we have basically this situation. We have hundreds of processes that are trying to interact with the resalloc server at the same time. So it is possible that it cannot withstand that many connections. So yeah, we will experiment with all of these in the next video, but right now I'm going to take a lunch and take a quick break, and then we will get back to it. So thank you all for watching. I hope you are not mad we didn't finish it just yet, but that's what I advertised. So see you next time, hopefully to see the result. Bye bye.